Now we're not muted. Okay. I'm really glad I saw that. But yeah, this is Goodbye 2021. It is rated for me. Right now my rating is 2110, so I am in danger of losing orange, but that's okay. Because if I just become purple, then all that means is that um I can do Div 2s officially. And is that really a bad thing? No, not really. So let's just read problem A. Given n integers, you can choose any subset and negate these numbers. Maximum number of different values. Okay, well, it's just, okay. Each value is up to 100, oh, negative 100 to 100. Okay, oh, we just missed 1 minute. Oh, never mind. Wrong answer, pretest 1. Wait, why is that 6? Hold on. In x an array, count at absolute value at x increases by 1. Oh, this is supposed to be count. That's a little better. Or not. 432. Oh, because right, 0. Good catch. If count at 0 is equal to 2, or I guess greater than or equal to 2. Let's try this again. It's not okay. We had a little bit of a rough start just now, but you know what? Wrong answer pretest 1 doesn't actually count for any penalty, so it's not bad. You have a string, you stand on the left side of the string looking right. Lexicographically smallest string we can see. First prefix. I think it's just like the descending sequence. So if it's like, because CBBC versus like CBA, but CB, what about CBB? CBBBB, C. Is AA? No, but like just normal A is better than AA. But if we have something like BB, is 2 B's is better than 4 B's, but if it's like B, and then just guarantee be a prefix. So if the first 2 letters are the same, then it's just like the single letter. Otherwise, we want to do like a descending sequence. Yeah. Okay, so we're given the length of the string and the string itself. Is that at least 2? No, give me 1. If n is equal to 1 or array at 0 is equal to array at 1. Or this is greater than or equal to. For int k is equal to 1 or 2. Then choices up to 1 inclusive. Like, if it's less than or equal to. Yeah, because it's A to B, but if it's B to A, then array at k minus 1 is array at k else we break. Oh, there's no space. And I meant to say array 0. Yeah. Can we submit? Please let me submit. I would like to submit my problem. Oh god, m2.codeforces.com. Goodbye. Submit problem B in Java. Okay, we got it. Problem C. It's good if and only if for any subsegment the following holds. The sum is equal to the average of the endpoints times the length of a segment. You can replace any one element with any real number. Okay, any real number. Oh, is this for every segment? So it's like the sum of these two is negative 1/2. Okay, so it always holds for segments of length 2. Right? Because the sum of these elements is just 1/2. Yeah. And so how do we satisfy? So if A and B are already fixed, then it's like A plus B plus like A plus B plus C. We want to make this equal to 1/2 a plus c times 3. So in other words, a plus b plus c is equal to 3 over 2a plus 3 over 2c. So in other words, we have that b is equal to 1 half at a plus 1 half at c. So 1 half at c is equal to b minus 1 half at a. C will be equal to 2b minus a. Okay, and so c is equal to this, and then yeah, so if it's like a, b, 2b minus a, and then d, the sum of this should be equal to 1 half a plus d times 4. So in other words, a plus b plus 2b minus a plus d should be equal to 2a plus 2d. These a's cancel out, so it's just 3b plus d should be equal to 2a plus 2d. So in other words, d should be equal to 3b minus 2a. Alright, so it's like a, b, 2b minus a, 3b minus 2a. This is b. Because the idea is that if d was equal to 3b minus 2a, then a plus this wait, 3b minus a would be equal to 6b minus 2a, which is true. Okay. So is it safe to assume this pattern keeps on going? Where for any two adjacent values, and replace any one element in the array with any real number. Okay, so what if it was b, 2b minus a, and 3b minus 2a? The sum of all these numbers is equal to 6b minus 3a. Yeah, 6b minus 3a. Okay. If we're given two adjacent elements, the complexity of this would be, for each n squared pairs, we do an O of n check. I mean, n cubed is too slow. Yeah, but n squared is probably okay. Yeah, n squared is fine. Or I mean, n cubed is fine. So it's like, for each of that, we do an O of n thing, where we just append a value to it. But if we wanted to do another value over here, then what would it be? It would be these two terms, like these first two terms, 3 times this minus 2 times this. So it's 3 times this, 6b minus 3a minus 2 times minus 2b, which is equal to 4b minus 3a, which extends in the same way. Alternatively, we could like brute force these values. Like brute force the first two values. Because it's like, this goes up to, if it's like AB, 2b minus a, if n is up to 70, this goes up to roughly 1, 2, 3, it goes up to 69b minus 68a. And the difference between okay, if we assume a is smaller than b by a value of 200, if it's smaller by a value of 200, because it could be like negative 100 and then 100, this would be negative 200 times approximately 68 times 200. What is that? Those are too many values to check. What if we just check if there's any two values, like from the minimum, then we can take these two values and then just extrapolate from that. Okay, I think that's the best way to do this. X is equal to n, because we can choose to change all of n of them. Yeah, I want to use different variable names for this. Y is equal to x plus 1, y is less than n, y plus plus. So if in order, it goes in some sequence. A, B, 2A minus B, 3A, or no, I mean 2B minus A. Wait, is it 2B minus A? Yes, 2B minus A. And then 3B minus 2A, and then 4B minus 3A, and then so on. Index 0, index 1, index 2, index 3. All of these are a difference of B minus A. Because this increases, oh, B plus A. Because this, both of these, oh no, wait, yeah. Oh, okay, what do we add on from here to here? We add a B, and we subtract an A. Add B minus A. So if we subtract B, yeah, difference between these is some multiple of B minus A. So you can get B minus A really easily. We can also figure out what this value is, and then we can get A, and we can get B. So yeah, value of B minus A. Difference is equal to array at y minus array at x. Oh, it's any real number though. Can we use doubles? I mean, I guess we could, since like the value, or the values themselves are relatively small. I don't want to open Zoom right now. Stop this. Stop this. Stop this. Final double. Something like that, yeah. Value at B minus A. Double difference is equal to... It's just over the difference of y minus x. And double A is equal to... Or I guess we can get B is easier to get first, because we can do B is equal to... We know if this is a difference from... Okay, so this is B minus A, yeah, plus B minus A, plus B minus A, yeah. Oh, excuse me. Plus B minus A. So difference actually works in the same way. Whereas just, okay, we can even do A first, because it's literally just array at x minus x times difference. Then double B is just A plus difference. And you double at N. Okay, so double at A, then 4 and I. Four and I is equal to 0, I is less than N, I plus plus. So if absolute value of array at I minus A is greater than epsilon, zero 2 0 3 0. Okay, that's not right. If n is less than or equal to 2, then it's always possible. Why is this 3 though? Okay, so it's based on negative 2 and 1. So in this case, b minus a is equal to 1. Wait, no, the difference of us, yeah, it's like by negative 1/2. So, okay, let's run this again. So it's probably just an implementation mistake somewhere. Let's yoink this test case, and then we care about, okay, if it's 1 and 3. That is not right. If x is equal to 1 and y is equal to 3. Oh! Right. Okay, hold on. Because it's like doubles. We don't want to use integer division. Yo, let me submit. Okay, we got C. Let's look at what the next problem to do is. Okay, it's just D then E. Okay, you're given an array of n integers and an integer x. Select the maximum number of elements in an array such that for any subsegment containing strictly more than one element, either at least one element in the subsegment is not selected, or the sum of them is greater than or equal to this. In other words, their average is that. So if we select an element, if we select an element, then that means that, what does that mean? By selecting an element, any subarray that contains this element. Oh no, strictly more than one element. Okay. Oh wait, no, but like at least one element in the subsegment is not selected, or this. So in other words, okay, what happens when we select two elements? Then the subarrays that are, then they're just subarrays between these values. These problem statements are really short. That's really nice. Let's see. Oh, I might want to use fast scanner. Like we just want the sum. Have an average. We want the subarray to have an average of at least that. If if this is selected, values can be negative, so we can't just. So it's not really something we can binary search. What if we consider the prefix sum array? Then the subarray sum oh wait, at least one element in the subsegment is not selected. Oh, okay. I thought it was like no elements in the subsegment is not selected. Okay. Okay. Um Okay, so for every left bound of a sub segment, maybe we can find the first right bound such that like the first right bound such that we do this. Because we want to turn all of them on. Well, okay, if we assume we turn some segment on in the beginning, so we want to ensure that. And if we do this one is turned off, and we can do like dp at this value. So maybe you want to maintain two segment trees. One of them is like, for given like the maximum number of elements we can turn on, assuming we consider a suffix from I to n. Then one way we can do it is the maximum number. We do this plus how many we can turn on from here. And this is like assuming no subsegment there. Whereas like either the first element or the element right before it is not selected. So in other words, we don't have to worry about any subarray going outside of its range. Because dp at n is equal to 1, dp at n minus 1 is equal to either 1 or 2. And then so in other words, dp at I is equal to the max of, I guess, I. So it's like from 1 is, because we can only select one element. Less than or equal to L, which is less than or equal to K, where K is like the longest subarray span that we're allowed. Yeah, we assume we always take dp at I. and then plus, this is just equal to L plus dp at I plus L plus 1. That's what it's equal to. So we can calculate these values of k pretty easily. Yeah, I think we just use an RMQ or something. So if we use an RMQ and then, or even just another segment tree would work too. But we would have to figure out where it's located, because the way it would work is that we would build a segment tree of all these prefix sums, and then we would have to find the first element in a range such that it contains like its minimum, and the minimum is makes it so that it violates this condition over here. So if it's made so that the minimum violates that condition, then we need to do something. I guess we could like just say we don't include this element either. Okay. First thing we need is generate all these k values. That's the most important thing we need to do first. So after that, so let's just take care of that first, where we can do T is only 10, right? Yeah. I'll still use string builder. In n an array. How much memory is it if we do, I guess 2 to the power 17, or I guess 2 to the power 16. That's, or 2 to the power 15 even. Yeah, 2 to the power 15. So 16 times 50,000. Oh, that's barely anything. Yeah, that should be fine. Yeah, million longs will not exceed this memory limit. So we could build an RMQ. Sparse table. you build it on the prefix sum, so these can be long. The table itself can be long. Long. Okay, so inclusive zero indexed means we do that. Are there any other changes that we need to make? Public void reset. K is equal to whatever the hell this is. Table for sparse table RMQ equals new. Well, okay, RMQ dot reset at n. RMQ dot reset at n. Yeah. Containing strictly more than one element. So int low is equal to this is just equal to 1. Int low is equal to 1, and high is equal to so array at I plus array at I plus 1. So if the sum of these two values is strictly less than this, then that means we can't k at n minus 1 no, k at I is equal to 1, and we continue. Otherwise we do int low is equal to, if we know it's at least 2, and the maximum can be n minus I, yeah, because it's I minus 2. Wait, what's the time limit on this? 1.5. I think I'll be okay. I really hope that's okay. So if if RMQ.query from, so if we query the p sums from I to mid inclusive, or I to I plus, I think I've just figured out the left boundary then. So I plus 1 up to n minus 1. Yeah, because if n is equal to, it's n minus 2 plus 1 is n minus 1. And if this is okay, then that's the best it can do. K at I and low minus I plus 1. So if we go from I to mid, or I guess because we don't care if it's like a single element. So it's just like minus minus diff. Oh wait, no, this isn't right because the value of x can change based on the length. Wait, okay, this logic over here isn't quite right. What would we do instead then? Maybe we can look at the smallest elements first. Where it's like we sort these elements, and then the moment we get 2 adjacent elements, we know that that means that one of these cannot be selected. One of these cannot. Oh wait, you know what we can do? Another way you can just think about this is if we sort all these elements in increasing order, and we like add them, and then the moment we get 2 adjacent pairs, or like 2 adjacent pairs, and also their averages, the average of this like complete subarray is like not satisfied, then what we can do is we can get the left and right endpoints, and then say because if we reverse the problem, we have like a bunch of these ranges at the end, and the condition is that we have to make sure that none of these ranges have all of their elements selected. Or in other words, if we flip it around, we just say at least one element in each range must be selected. And we have to essentially find the minimum number of ways we have to do it. Wait, that's a better way of doing it. That's such a better way of doing this. Let me try. Yeah, because now we just need union find. Let me try this. Do we still need prefix sums? We don't even need prefix sums anymore. We just need to modify union find a little bit. Because because we need to store the size, the left endpoint, the right endpoint, and the sum. So class DSU. Or public long sum. DSU size left is equal to new int n. Or new long at n. DSU is equal to left at I, which is equal to right at I, which is just equal to I, and then the sum at I is equal to array at I. Okay, find merge. So how do we merge this? So DSU at f of x leads to, so f at y should be the updated one. Min of left at f at y, left at f at x, right at f at y is equal to max, right at f at y, right at f of x. And sum at f at y plus equal to sum at f of x. And we also updated DSU itself, right? Yeah. Okay. So n an array. Where we do return, I want to do an increasing value order. Public int left, public int right, public range int a and b. Left is equal to a, right is equal to b. And then we can do x and indices. Wait, okay, so if there was a range from here to here that we couldn't disable, that we have to make sure we select at least one element in here. Something greater will also be the same thing. I have to go to the bathroom. Hold on. Okay. While I was in the bathroom, I realized a trick where we can reword this condition to if we subtract x from every element, then we just have to make sure that the sum of every subarray is at least 0. So if we did that, then instead of checking like, all we would have to check to see if it's like greater than or equal to 0. And then for every like for every range like that, we would just have to, yeah, that makes this binary search solution work with the RMQ. And this doesn't work because this doesn't account for every like for every like possible thing. Okay, well that's as far as we can go. That's okay. I'll figure something out. Yeah, because the way this works is that basically what's going to happen is that if we subtract everything by x, then we just have to check to see if the sum of everything is 0. I is less than n, I plus plus, array at I. And then this is like sparse table RMQ equals new sparse table at this. RMQ dot reset. Except now instead of using the DP, we can instead just say like for each boundary, where's like the first thing that it happens? Because obviously if something is turned off in here, something is also going to be turned off in. It's going to be triggered in here. So yeah, we can just use ranges to do that. So reset. Okay. Long p sums is equal to new long at n. Okay, well, we figured it out, but that took a little too long. P sums at I equals p sums at I minus 1 plus array at I. Then RMQ dot left p sums. And then we just do for public and left, public and right, public range A and B. Left is equal to A, right is equal to B. And then we can just do wait, if it's n minus 2. So in other words, given the prefix sums, you have to find the first occurrence of the negative element, which we can binary search for. Or I guess like first occurrence of negative element, like subtract the prefix. If I is greater than 0, prefix is equal to p sums at I minus 1. So int low is equal to high, and well, it's like I plus 1. Actually, let's do p sums at I. And low is equal to high, and high is equal to n minus 1. It's like the the rightmost boundary. These are possible boundaries But we never want an interval to start here because we never have to turn off only n minus 1, in a sense. Yeah. So while low doesn't equal to high, and mid is equal to these values, and then if RMQ of query I to mid minus prefix is greater than or equal to 0. Yeah, because this is at the very end, this will give us wait, no, but this is an endpoint at 0. Prefix is equal to prefix is equal to p sums at I minus 1. So when low is equal to I and high is equal to I guess I plus 1. Yeah, because even if the second to last element is I plus 1 up to n minus 1. So I plus 1 to mid. So if RMQ.query I plus 1 to low minus a prefix. If this is strictly less than 0, then that means the range is I to I plus 1. Because even if it's like, yeah, that means like I plus 1 it's like their prefix sum, I plus 1, I plus 1. Oh wait, is this min or max? Okay, go to min. So if we do min minus this prefix, then it's just I to I plus 1. Else ls dot add new range I mean, I guess it's possible that like even among the whole thing, I plus 1 to n minus 1 inclusive, like else if low plus 1, because if it's equal to n minus 1, then that means that there's no subarray starting over here. That makes it bad. In which case, this doesn't have any restriction. So I to low plus 1. There we go. Okay, so we have a bunch of ranges, right? Let me figure out. Yeah, I think I'm spending a little long on this, but that's okay. We should still have a good amount of time. Assuming we can, code forces will load. Thank you. It's this problem it's similar to, at least the part of it. See if our solution will load. Like over here. Like it's literally just the exact same as over here. And except the ranges get sorted by this comparator over here. 4822. Small correction. N minus res. Let's move on to problem E. Hopefully this works. I just hope it doesn't TLE. Runtime error. Wait, hold on. Runtime error on test 2. How come? rmq.query. rmq long. Return. Maybe it's a reset function that's a little weird. Inclusive 0 indexed. Oh, is it if I was equal to 1 or 2 or something like that? And then, okay, and then 2, 2, 2, 1. No? Okay. 1 and then 2. Runtime error. Why would it be a runtime error? Okay, what if I is equal to n minus 2? Wait, where could a runtime error be occurring? That's so weird. That's really weird. What if we do something with like a bunch of negative values? Like, for example, if we did 5 test cases, first we did 1, 2, and then 8, versus like 2. N was equal to 2. 3 were its values. 18 was this value. And then it's like 1, negative 12, 2. 1, negative 12. And it's like 4. One, 1, 1, 4. While load is not equal to high. What kind of runtime error could it be? what? What was a runtime error? Okay, whatever. I didn't think that would fix anything. Okay, well, I guess it fixed something? Question mark? Okay, a lot of people already have E, so that's good to know. Anton, oh god, oh no. No. What do we do though? Yeah, I guess we just do E. Lexicographically small enough. I need to charge my map. How much time do we have left, by the way? 48 minutes. That's not too bad. You're given two strings, S and T of equal length n. When moving a swap any two adjacent characters of the string S. You need to find the minimum number of operations you make a string S lexicographically smaller than a string T. The minimum number of adjacent swaps. Or -1 if it's impossible. Oh, it's only impossible if T is like the most lexicographically smallest permutation. That's the only time it's impossible. I want to use fast scanner for this as well. S and then T. Public seg boolean sorted car array. Is it just lowercase? Yeah, lowercase. So array at I is strictly greater than array at I-1. And return false. Otherwise we return true. Okay. Or wait. Yeah, that's better. Let me just do this so it makes more sense to me. There we go. If it's sorted, then it's not possible. Wait, okay, in any one adjacent swap, is that true? Does it have to equal to the string at first, or no? I don't think so. Or maybe it does. Oh wait, they're not permutations of each other. Wait, okay, hold on. So if bad okay, we can just do string input 1 is equal to next line dot trim input 1 could just do input 2. And so if input 1 dot compared to input 2, if this is less than or equal to 0, or like if the sorted versions are, yeah, so like if input 2, we want this to be lexicographically smaller. So like if if it's greater than or equal to this, static string car array or in car C an array count at C minus this plus plus. So while count at C minus minus. So if a completely sorted version is this, okay. Then that's something we have to keep track of. Run a separate line. The minimum number of operations need to make string S lexicographically smaller than string T. Okay, so then otherwise we know it's possible. What if we brute force over, we iterate over the first position that S is different in T, in which, and obviously it's like less than, then we assume everything before it is the same. And then, so the first step might be to think about how can we get here first? Okay, so if we want to make a prefix the same, okay, if we move this over here, you can move this like 1, 2, 3, like 1, 2, 3, or you could just do 1 and then 2. Wait, is that just better? AABBA. So AABAB. Or if we do ABAAB. Oh yeah. Okay. So what is one way you could do this? We could iterate over that, maybe. Like, iterate over the actual character. So it's like, we force some prefix. And then... Yeah, so we force some prefix to happen first. And then at the end, it's just like, how many moves can we move this up to here? Yeah. It's like, we're basically just sorting it first. Where it's like, we have some sorted prefix cost. Yeah, so it's like for each letter, we want to know what the position over here is. If we add on to a range, yeah, so it's like, if we use a range bit for the locations, Ray deck 26-1. So look at array at I minus this dot add at I. So that's a location. So we think about the cost of a prefix. Did I unmute myself? Okay, I did. So assuming that the prefix is valid, then we want to make some cost. Okay, so assuming a prefix is valid, we can force some cost of a prefix to happen. So for example, we can do I guess something like if, how would we do this? I want to use, so we use a bit to figure out the amount that these like original indices have been shifted to like their real index. What's the best way to do this? Maybe just a regular family tree. And then we could just like show which elements have been disabled. Yeah. I like that a little better. So we do this. Everything is one index so far. So what if I make it 0 indexed? If this is all 0 indexed, then yeah, so for example, we want to do 0 to 1. It's really 1 to 2. 2 minus 0. Yeah, this was 1 indexed. Turn it into 1 indexed. Okay. Bit dot add I and 1. So if looks at target at I at size is equal to 0, we break. Else we do okay, so if this otherwise and look and to remove x is equal to dot poll, and then we do prefix cost yeah, it's like hierarchy, so this is still like a first, second, third, but then everything over here gets shifted down by 1. It's like bit.find at removed x. Yeah, find is just up to and including -1 because we don't, yeah, and then we just do bit.remove, well, bit.add at removed x, we add -1. Yeah. And so we just do for int characters equal to 0. Target at I minus this. Like add last. We add into the last. We pull first. So if locations at C dot size is strictly greater than 0, then we get int x is equal to locations at C dot get first, like the first index. And this is essentially, we assume we remove it to here. So res is equal to min at res prefix cost plus bit dot find dex minus 1. -1022. Oh, wait, hold on, compile it. That's going to get a compile error. Because I need to uncomment fast scanner. Okay, we got E. E was, in my opinion, much easier than C. Like, way easier than C. Like, they should have been swapped. But, you know what? It's whatever. What is Anton doing? Okay. I'm scared to ask what Anton is doing. What to do, though? What should I do right now, though? Yeah, like those definitely speed forces for sure. 32, 20. Should I read F? I guess I could read F. I'll read H as well. Or just quickly look over it. Okay, that looks like a math problem, so probably not. You need to find number pairs of vertices such that this, and after adding this to the graph, it has a Hamiltonian path. Find the number of pairs of vertices. Okay, so the fact that I don't remember what Hamiltonian path is probably means I won't solve that problem. Graph path between two vertices that visits each vertex exactly once. Oh. Visit each vertex exactly once. So it's just a cycle of length n forms. That's basically what it is. Yeah, that sounds hard. Problem F, you're given, okay, see if there's any hacks happening right now, because any vertex hacked. There's one A that's been hacked. What was my A? My A, oh, it's probably fine. Yeah, because we just count this, res is equal to 0. For an x and count each frequency of an element. We can add at most 2 frequencies to it. But if there's at least 2 zeros, then we can only add one of the zeros. So yeah, subtract 1. That looks fine. Okay. So what about this? Simple undirected graph with n vertices and m edges. Each edge I is colored in the color Ci, which is either 1, 2, 3, or left uncolored. In this case, this is equal to this. Edge I is colored in the color Ci, which is either 1, 2, or 3, or left uncolored. You color all the uncolored edges such a way that for any 3 pairwise adjacent, the colors of these edges are either pairwise distinct or all equal. Just find a coloring. Okay. I think I'm gonna lock my A. because it seems like a hard problem, so I don't think I'll be able to get it in that time. And the only problem that has hacks on it is A right now. So we'll lock A. Let me just think about this a little bit more, just to make sure it's okay. The absolute value. So like either like -2 or like 2, for example. Then we can only make those 2. If count at 0 is greater than or equal to 2, then we subtract 1. Yeah, that looks fine. Okay, let's try hacking people. I should probably turn off dark mode for this. Pushback. That's an unordered map. Absolute value ++. If m.find I don't think 0 does anything. I have a potential like case that could break solutions. I'm not sure whether it's like the actual case or not, but I think it's definitely worth trying. So, especially when the solution is just like short to type up. Let me just do this. C++. Nope. Yeah, I don't have my monitor with me right now, so this one's going to be a little bit harder to like implement in terms of hacking, but includes bits.sdhd++.h using namespace std, define in as long inline void io. If and def online judge array open input.txt r stdn array open output.txt w std out. End if int main io int t cn at t while t minus int n is equal int n cnn vector int a. While this is less than n, we can do something like a.pushback s unordered map int m. Not like blowing up an unordered map will matter right now. And count equals m.size 0 equals 0 for auto it and m. If m.find negative it.first is equal to m.end and it.second is greater than 1. so let me just open up problem A to make sure this works on samples. Include bits dot what? Oh, bits slash, my bad. Run 431. Okay, so I have a test case in mind where if it's like 4 3, so this should be equal to, the last number in here should be equal to 2. I think if it works on this, then I think it's fine. Yeah, okay. It's probably okay. Let me turn off dark mode, because I think it's easier to figure it out this way. Okay, over here. If m is less than 0, then we negate it. Else if this. If it's greater than 0, okay, that should be okay. That looks okay. Okay, so it's for each value if temp, or no, result is this. If temp is not in result, then we add. Also, if negative is not in result. Okay, that looks fine. What is our rating delta, by the way? Because I know I solved D really slow, which might be because I think that's probably the reason why I didn't do as well. I mean, still I'm doing okay, I guess, but I could be doing a lot better if I wasn't so slow on D. If k is equal to 0. Okay, so this is frequency. Yeah, okay, that looks fine. If ff is equal to 0. Okay. I'm gonna go up here. map at this. If a value dot second, okay, so if a second value, if it occurs at least twice, then this will happen. Are there any other hacks happening? Any problem that's been hacked? It's only this person. And it was A, right? Yeah. Let's end login. It'll probably be fine. Wait, what's... Because of 1.5, right? What was the runtime on this? That should be fine. I think that's fine. This was a 1 second time limit. How long did it actually run? Okay. Problem C, I think is okay. If x is equal to 0, if not z increases by 1, otherwise we do this. What could that hack be? It's like, what could it even be? Plus 100. Wait, so if both are greater than 0, one of them is at least 2. Okay, so both of them. So one of these is 0, but okay. I don't think I'm getting any hacks out of this. If this is equal to 0, also second is at least 2. There's 8 more minutes. C at AI is equal to 1. What is this bullshit? Oh, okay. 4. Oh, you just don't increase it if it's 0. Okay. Else if I'm gonna try this. Oh, define LL as long. So LL n then K. C and an N. M plus 9. Vector LL V. Map. Map at array at I is equal to 1. V dot push back R at I. Else if map at RE is equal to 2. Then RE is equal to RE times -1. Map at RE. So if map at RE is equal to 1, V dot push back. I think this probably works now that I actually looked at it. Yeah. I'm feeling that one hack was just someone being really stupid. That's probably what it was. Aside from that, what are you doing? Oh my god. No. Anything interesting happening recently? No. Size is equal to so if I already had it before, Then we insert it again. Okay. These are probably all okay. Yeah, that looks okay. Not really sure what could be the hack, but aside from that, nothing really seems to pop up. Yeah. Okay. All right, that's my contest done. Let's see what my final like delta is. Right now it's plus 65. So yeah. We're not getting 2200 back, but hopefully we'll still gain rating. I mean, we will if we don't FST, but yeah. All right, that's about it. Yeah. As you can see, I am currently technically cyan right now. Yeah. That's fun. But yeah. That's pretty much it. I was gonna, where? Okay.